This will be the first lesson in trig ratios or trigonometry, and Pythagorean theorem is what we're going to look at specifically today. Okay, so hopefully the learning goal for today is going to be able to you should be able to use the three primary trig ratios. Okay, and then being able to use Pythagorean theorem to solve for a side length. That's also going to be important. Okay. So your success criteria is, can you state what the three primary trig ratios are relative to a triangle? Okay. And then can you label the triangles and solve for the missing information? Okay. Those are your two success criteria. Okay. So if we took a look here, so everything we do today can only be used if you see that, and we know this as being a right angle. Okay, we cannot use what we're doing today on other kinds of triangles that don't have a right angle, and I know that kind of looks like a right angle, but it's not. Okay, unless you see this, you cannot use what we're doing today. Okay, so the questions you will see today are going to have the right angle in it. Okay, so you don't have anything to worry about for today. Okay, so you're just going to be able to apply this. So in any right angle triangle, okay, the sides can be referred to with respect to a given or indicated angle. Okay, the angle is sometimes called the angle of reference. Okay, or it can be named with a Greek letter colored in, or referred to by its vertex, so like angle A. Okay, so in triangle ABC, theta or angle A is the indicated angle. Okay, you can see that I guess they were making reference to this particular triangle here, right? So angle A is the indicated angle if we were to talk about this triangle. Okay, label the sides as opposite and opposite the indicated angle. Okay, O, and adjacent to the indicated angle A, and hypotenuse H. Okay, so we just want to label these triangles with those letters. Okay, and we can kind of see how this is going to work out. Okay, so depending on where you're standing, okay, so in this case, let's just look at the first triangle here. Okay, depending on where you're standing, this we typically label the corners or the vertices of the triangle with the capital letters. Okay, and then opposite side lengths of the angle are labeled with the little letter. Okay, the non-capital version. Okay, so this is going to be little c and this is going to be little a. Okay, and then I'll do the same. You can see it here already done, which is nice. Okay, now what this question is asking us to do, okay, or just the first little part of this, is to label the triangles such that we're looking at the angle of reference, and I want to label opposite, adjacent, and hypotenuse. Okay, so what I'll do here is I'll do that in red. So little c, if I'm standing here in the corner, right, at angle C, and I look across, this is going to be opposite because it's opposite of the angle. Okay, angle of reference. Okay. Now what's nice is wherever you see this 90-degree angle, opposite of that is always the hypotenuse. Okay, it's always a hypotenuse because we define the hypotenuse as being the longest side length. Okay, and what's nice about triangles, longest side lengths go opposite of biggest angles. Okay, so biggest angles go with biggest side lengths. The second biggest goes with the second biggest, and the smallest goes with the smallest. Okay, and so that's a hypotenuse. And then by default, okay, there's no thinking involved. By default, this must be adjacent. Okay, that's the order I always do it in because I find it the easiest and it's very difficult to make a mistake. So if I'm standing here again, we'll do the second one here. Okay. If I'm standing at angle A, I'm going to look across and I see that, that's going to be opposite. Okay, I can get rid of that. Then I can go, okay, where's the 90-degree angle? It's right here. Okay, this must be hypotenuse. And by default, or process of elimination, this must be adjacent. Okay, now that's labeling the triangles. Okay, so that's that takes care of this part of the success criteria. Can you do this? Okay, because this is important. You're not going to get the right numbers or the right answers if you cannot label these triangles with the appropriate information. Okay, so if you recall, we have this nifty little saying, okay, and I'll write it here. We have so ka toa, and you should have done this at some point, I'd imagine. Okay, now sine is always opposite over hypotenuse. Okay, cosine is always adjacent over hypotenuse. Okay, and tangent tangent is always opposite over adjacent. Okay, you can see how each of these letters come up here. Cosine, cosine, and tangent goes with tan. Okay, and so what I want you to do here, okay, this is how you actually write out the three primary trig ratios. These normally in a question, A will be a number, little b would be a number, and little c would be a number. You'd have some information here, right? But you're still going to label them as opposite, adjacent, and hypotenuse. So what you can do is actually write this out. So it's sine theta is equal to, we'll do we're going to call this triangle 1. Okay, I think I tried to label that here, but this is triangle 1. Okay, the first one. And so what I want to do is label or write out, the trig ratio from triangle 1, trig ratios from triangle 1 with the side lengths attached to opposite, adjacent, hypotenuse. Okay, so with sine theta was opposite over hypotenuse. So I'm going to go find the side lengths that are opposite and hypotenuse. So it looks like C is going to be opposite and the hypotenuse is going to be B in this question. Now those could be numbers, right? We could totally, we'll see down here in some of these other examples, they're numbers, right? Cosine is adjacent over hypotenuse, okay? So in this question, I see that adjacent is here and it goes with A. So it's A over hypotenuse is again B. Okay, and tan theta is going to be, let's take a look. Tan is opposite over adjacent. Okay, so we're going to go find opposite. Opposite is right here with C. So it's C over adjacent is A. Okay, these are all could be numbers. It could be whatever they are. And we'll see down here when we do an example, and it might make a little more sense. You can actually make the connection. But all I've done here is just write the letters from each of these in their corresponding spots based on the trig ratios. Opposite hypotenuse, adjacent hypotenuse, opposite adjacent. That's all I've done. Okay, so given triangle ABC below here, okay, state the three primary trig ratios and then find the angle. Okay, so what I want to do, and this is an interesting exercise because what we should be able to do is find the exact same angle using all three trig ratios. Okay, and I'll show you how to use the calculator to do that. Okay, so let's start with, well, you can always write this out if this helps you. Okay, this always helps me. You keep things straight in your head with what goes with what. Okay, so let's label the triangle first. Okay, this is my angle of interest. I'm standing here in the corner. Okay, and I'm going to look across. So this is opposite. Okay, and you could even put a box around the side length with the whatever you've labeled. Okay, so we'll get rid of the arrow now, and then we're like, okay, where's the 90 degree? It's right here. So what's opposite of the 90 degree? The hypotenuse. The hypotenuse is 5. Okay, because it's the biggest side length, and it goes opposite the biggest angle. Okay, and then by process of elimination, this must be adjacent. Okay, so now we're able to write out sine theta is equal to opposite over hypotenuse, because that's what it's telling me to do. So it's 3/5. That's your trig ratio, 3/5. Okay, go to the next one. So what we're doing is stating the 3 primary trig ratios. Okay, so cosine is adjacent over hypotenuse, 4/5. Okay, and tangent is opposite over adjacent. That's what it's telling me, right? So opposite is 3 over adjacent is 4. Okay, those are your trig ratios, your 3 primary trig ratios. Okay, now what's interesting is I can actually find the angle theta. So angle theta, what you can do is actually find what you want to do is sine theta is equal to 3/5. Okay, we can do this. That's just me copying from here. Okay, so what we can do is actually find what 3 divided by 5 is. Okay, it's 0.6. So you get sine 0.6. Okay, now here's the cool thing. You can actually go, I don't know if this has second function. I wonder. What you need to do on your calculator, and I don't seem to have it, which is kind of annoying, is in order to figure out the actual angle value, you'll type this into your calculator. You'll go, some of you might have the scientific one, which we would go sine inverse 0.6 should equal an answer, whatever the answer is. Okay, and then you could find all of these. Okay, you could do this over and over again for each one of these. Okay, you could go cosine of theta is equal to 4/5. Okay, so cosine of theta will equal 0.8. Okay, and then you could go cosine inverse of 0.8 will equal the same angle that's here. Right, it'll be the same answer in both of those. It should be. Okay. I'm going to end the video here. I'm going to see if I can figure this out, okay, with the calculator. Maybe just missing something. But I'll pick up here in this next video, and then we'll do the bottom questions, these 2 questions here, and then you guys should be good to go with the homework, okay? So that's it for this particular video. Writing, the key part, takeaway from here is writing these 3 trig ratios, okay? Can you do this? This is important, okay? And then finding the angle afterward, which you should have done in the past. It's just my calculator's not cooperating. Okay, so I'll see if I figure that out. But if I ask you to write the 3 primary trig ratios, step 1 is label the triangle, and then come down here and go fill in based on SOHCAHTOA. Okay, and just write me the ratio. The word ratio, fraction. Okay, these are fractions. Okay, so that's it. I'll end here, and then I'll jump in and show you how to do the next two questions in a minute.